There is an island in Southeast Asia with some of the most unique animals on the planet. The island of Sulawesi looks like a four-armed sea star and is the largest of the Malay archipelago. The Malay archipelago is a collection of continental crust and oceanic islands at the southern end of the Alpine Himalayan belt in Southeast Asia. It is located at the convergence of the Eurasian, India-Australian, and Pacific-Philippine tectonic plates, which still causes so much seismic activity that tsunamis and earthquakes are a common occurrence. 45 million years ago, a large landmass separated from present-day Asia, taking Asian plants and animals with it. During this time, oceanic volcanoes were creating mountains that were being pushed together by tectonic plate movement. Around 10 million years ago, the waters separating these landmasses from Australia were the shallowest, which allowed Australian animals to migrate over to some of the Sulawesi landmasses. The island didn't reach its current form until about 1 million years ago. I am part of a team of scientists from around the world, completing a large-scale biodiversity assessment of these mountains on the island of Sulawesi. That's me! My name is Rachael Joakim, and I'm a fifth-year PhD student at City College with malaria expert Dr. Susan Perkins. What's my role on Sulawesi, you ask? Identifying the parasites of all these amazing species of birds. Our bird team is trying to learn how birds disperse to different elevations in different parts of the island. Our current theory is that birds, because they can fly pretty well, first inhabited these mountains when they were still separate volcanic islands. As the mountains grew and the peaks rose in elevation, some of the original birds stayed on the peak, while the rest moved down the side. Newer species of birds arriving to the island likely inhabited lower elevations. These independent communities were then joined millions of years later, once there was one continuous landmass. In order to catch birds, at each mountain we set mist nets in the understory of the forest, from the lowland jungles all the way up to the summit. We take blood samples of every bird we catch, which we use to sequence DNA and look for malaria parasites. Do similar birds in lower elevations actually have different DNA? Do they have similar parasites to higher elevation relatives? Did each species of malaria stay with the bird species they came with, or did they move to other species once they came to the island? By looking at the differences in DNA sequences and parasites together for each bird species, we can answer these questions, helping us to understand the complicated past of the most unique island in the world.